So today we are going to look at the last section of notes. You're going to need this crazy chart. So the chart with all the numbers. If you can keep that on the side of your desk, this is called the standard normal chart. This is all the probabilities that exist under that curve. And then in your packet, you're turning to page 17. All right, so page 17 in your packet. Ethan, page 17, right?
Yeah.
Yeah.
I don't want to get my paper loose and you want I don't segregate against sexes, so I talk to both. I'm only scared of Julia when she's 6 feet high.
Yeah,
Exactly. You're trying to attack me. You want to try to right now?
She was. I was pretty scared.
Sorry if it won't happen again.
All right, so today we're talking about z-scores. This is just an extension of the empirical rule from yesterday. So the empirical rule says if you're one standard deviation away from the mean, that's 68% of your data. 2 standard deviations is 95, 3 is 99.7. What happens if you have a standard deviation that is between 1 and 2, like 1.5, 1.75, 2.25? So we can't just say that, oh, that doesn't exist, because those numbers do exist. So that's what a z-score is. So it's a more specific or precise standard deviation that just goes like beyond the empirical rule. So not just worried about those 3 standard deviations, but what about the values in between? So to find or calculate a z-score, it's a tiny little formula that involves 3 letters besides the z for z-score. So to calculate a z-score, you're going to take x, which is the value they're going to give you, minus the mean, and you're going to divide that by the standard deviation based off of your data. So x would be the given value, the given number, x with a little bar, remember that represents mean, and then standard deviation is that sx. So a z-score is just a more precise standard deviation value. So not just saying I can only be 1 or 2 standard deviations away from the mean, saying I could be 1.3 standard deviations from the mean. And then that correlates with that crazy chart of numbers, because then I know what the percentage is. So 1 standard deviation is 68%. Well, what's 1.782 standard deviation? Something like that.
Yeah.
So we're going to be using both, just to kind of get you to think about like what type of problem this is associated with. If you look at the first problem, this is something I think would be cool for us to do in the school district, but probably costs a lot of money. But we have an arithmetic skills test, math test essentially, that the district gave to every student. So some type of basic math test given to all the students in the district. So that means my 1st grader would have taken it, my 4th grader would have taken it, you guys would have taken it. Well, yes, but it's the same exact test given to everybody. So it's not like changed no matter what grade. So it's not changed just because you're going to get an easy test because you're in 1st grade or a hard test because you're a senior. So they give us 3 age ranges over here. So 10 through 12, that would be if you're in like 4th, 5th, 6th grade. And then you can see the mean, the average number that they got correct. Now, I don't know how many this is out of. I would guess maybe it's out of like 200. So the number of correct is saying for the 10 through 12-year-olds, 4th to 5th or 6th graders, got about 102.4 correct. And then the next age group, 13 through 15. So think that's like your middle school age, like 7th, 8th, 9th graders. They have more correct, which makes sense because they're older. So 128.7, and then the sophomores, juniors, seniors at 16 to 18 age group have 146 answers correct. The standard deviation for each group is also given. That just like tells us how far the person was away from the mean. So question A here, part A, Gina is an 11-year-old, so 5th grader, who had 113 answers correct. Seems pretty good.
Wow.
Michelle is an 18-year-old, and she had 157 answers correct.
That's kind of embarrassing.
Is it okay to compare their scores directly and say, well, Michelle obviously is smarter since she has 157 correct?
I mean, yeah.
She has more experience, so
she
she
is-
better have more correct,
She's
right?
also she is smarter than.
You think so?
I mean, you're smarter than me, and you're older than me, so.
So it says basic math. So we're going to see if we can actually determine which one of these scores is better. So because Michelle has 157 correct, does she have a better score? Did she perform better on the test than Gina did? And that's what a z-score can help us decide. So we're going to create a z-score for Gina. And we're going to create calculate a z-score for Michelle. So to find a z-score, you take the person's value that they had on the test. So Gina scored 113. You subtract the mean for her age group. So what's Gina's age group's mean? 100 and 2.4.
She's above average.
Yeah, so that's good. She's above average. And then Nina, what is her standard deviation? 16.3. All right, so before we calculate Gina's, let's just fill in the numbers for Michelle as well. So Michelle had a score of 157. For Michelle's age group, what was the average, the mean? 146. And then we're dividing that by the standard deviation of 18.1. Okay, so in your calculator, make sure you subtract first before you divide. This is true. But the numerator of fraction is like having invisible parentheses around it. And parentheses go before. Brandon?
Gina is 0.65 and Michelle is 0.6.
Can you give me two decimal places?
1 because it was 0.607.
Okay, so we'll say 0.61. Always use two decimal places, so we'll kind of correlate with that with the chart. So I have a little diagram over here of a basic empirical rule graph. It's not as fancy as what's drawn in your paper or your packet, but the mean is in the middle. Standard deviations, that's what the numbers represent. So I'm 1 above, 2 above, 3 above, or 1 below, 2 below, 3 below. So the further away you are from the mean, does that mean you did better or worse?
I'm probably gonna say
Depends on which way you
better.
Depends on which way you go. So if you're the positive values, that means the further away from the mean on the right side, the better that you would do. So Brandon, between Gina and Michelle, which one actually performed better with
Gina.
Gina did? So because Gina's z-score is higher, Gina performed better with the people in her age group compared to Michelle performing compared to those people in her age group. And I know that the numbers are still pretty close. They're only 400s away. So Gina still performed better compared to her peers.
Michelle's still pretty smart.
Yeah, still pretty good.
I think she's
Yeah.
had a bad day.
Probably.
No, yeah,
All right, so the next question then, we're going to try and use this chart. It says, what percentage of the students did better than Gina? So if you look in your chart, we're going to see if we can find this out. In the chart, we are going to look up 0.65, and I'm going to show you how to look up 0.65. So just take a peek at your chart. So looking at the far left of the table, the far left has a Z, and then below that Z are numbers. This 6, that 0.6, is what we need to find in that first column. So the tens place, the tenths place, I should say, and the ones. So the ones and the tenths place is what's in the first column with the Z's. The second number is the 100th place, and that tells you how far to go over on the chart. So we're going to go down to 0.6 because my number was 0.65. So we're going down to 0.6. And then we're going over to the column that has 0.05 because it's 0.65. So all the way over.
Oh, I'm on the wrong side.
You have to make sure you're on the positive,
So what was it?
I was like, I cannot.
positive side.
0.7.
Okay, so we have 0.7422.
So that's just the answer?
Okay, so let's write that down, 0.7422. How can we convert that to a percentage, or what is it as a percentage?
74.
Yeah, times 100, move the decimal place over twice, so 74.22%. Now, if you look at the top, there's a little graph with shading. Is this the percent that she did better on, or is this the percent that did better than Gina?
She did better.
Right, so this is the percent that she performed better than. Because in the chart, it's shaded to the left. So that means up at the table, like in this picture here, if this little X represents Gina, that's the amount that she performed better on the test. She performed better than 75% of her peers, rounding it. But we want to know what percent performed better than her.
So you subtract 1.
Yeah, so you subtract 1 from it or subtract it from 100 to get the complement. So still using that complement. So Nina, 100 minus 74.22% is
25.78%.
25.78%.
Yeah, that's still a decent amount. Over 1/4 of the group.
Yeah, so about a fourth of the group did better than her, but she still performed better than 3/4 of the group, or 75% of her peers, which is still pretty good. It's more than half. Questions? So a z-score gives us a more precise value than just saying 68%. Now we can say, well, 74.22% would be the value that she did better than her peers. So there's a second question underneath that we're going to still try and use this information, use z-scores, trying to look things up in the chart. And this deals with a group of women and their heights. So it does say women, not girls, so I would assume like 18-year-olds and above. Normally distributed with a mean height of 64.5, so 50 or 5'4.5". Standard deviation of 2.5. So this group, they're saying like their average height is 54.5 feet 4 inches, 4.5 inches, which makes me feel pretty good. I'm only a little shorter than average. That's not bad.
Oh yeah.
Yeah, right? So for question A, it says find the probability that a woman is at most 58 inches tall. If you're 58 inches tall, how tall are you? 4 foot something, right?
My grandma's 4.
You're 4 foot 10 inches.
Oh, that's
Now, no one yesterday was 4 foot 10 inches. Everybody was at least 5 feet, so nobody's below the 5 foot mark.
Oh yeah.
In order to answer this question, we need to find the z-score first, because you can't use that fancy little chart until you have a z-score to reference. So how do we find the z-score for this woman who's 58 inches tall? What do we have to do to find the z-score, Chelsea?
It's 58 minus 64.5 over 2.
Good. So you take in this case, the person's height, subtract the mean, and then divide by the standard deviation.
Nina?
What?
Negative 2.6?
Thank you for covering for a week.
And it's exact, right? Okay, so I'm just going to throw a 0 in the back of that so that we have the hundredths place. So this is negative because the person is shorter than average. It's okay to have negative values. So now looking in your chart, make sure you're on the negative side. So you got to flip it over. On the left, you're going down to negative 2.6. So follow down to negative 2.6. And then really it's negative 2.60. So 0 means that we're using the first column. And that number is 0.0047. So 0.0047 as a percentage is only 0.47%, less than half of a percent
Wow.
of the people are her height or small, in this case of women. So 0.4% of people women are smaller than 58 inches or 4'10". The next question says find the probability that a woman is at most 70 inches tall. So if you're 70 inches tall, you would be 5 feet 10 inches. So you're a whole foot taller. Savannah, how tall are you? Okay, that's what somebody in fourth period thought that that's what you were, and I was trying to think from yesterday. So this would be Savannah.
Wait a second.
Who just said Savannah Powers? Yeah.
Because I don't remember. I'll have to think about it. But it's somebody in my fourth period. And I was like, who's 5'10"?
Was it?
Yes.
So it wasn't
That
that.
makes
No, it's not. It's not weird. It's okay.
I was like, it was Emerson's.
All right, so let's find what the probability that a woman is at most 70 inches tall. That means 70 inches or less. This should be hopefully most of the females. Savannah, do you know many people that are taller than you right now? Like in your grade? Female? No. Asia, I feel like yesterday Asia,
Oh, she's
I think
taller
Asia
than
was
that.
I feel like she may have been
70.
taller.
Wait, that is 70. Wait, I'll look.
Yeah, well, we wrote it down yesterday. Yeah, we saw.
She might be 72. Oh yeah, she is 72.
Okay, so Asia's going to be our very small percent that would be taller than this. All right, so what's this Z-score value? Should be positive because we're taller than the average. Isabella? 2.2. And again, tack a 0 on there so that we have the hundreds place. So going back to that little chart, flipping it over again to the positive side, you're now looking at 2.2, so going down on the left side to 2.2, and then it was 2.20, so you're in that first column, 0.9861.
That's how much is taller than?
Yes. So that would be 98.61%. So Savannah is taller than 98.61% of females.
Nice, Savannah.
That means Asia
Good job.
is one of, like, what, 1.39% of people are taller than that? So Asia's one of that 1.39%.
Oh, yeah, Asia, give me a high five right now.
She's not even here for us to be talking about it. Any questions?
She's like a foot.
All right, so there are, I think, 4 more examples that I need to make sure that we talk about. So if you can flip over to the next page.
Oh, so gentle.
I love that. It was so cute.
Oh, very sweet.
This is a quick chapter.
I can't wait to buy this cat.
I'm so excited.
All right, so the last set of examples, ladies and gentlemen, I need your attention please for a couple of minutes. For example 5, it says sketch the standard normal curve and shade the region under the curve for values of z less than the given score. So I have 2 curves up here. Here would be my standard curve on the right side of the board. So essentially we're going to quickly make a basic little graph. We don't know what the numbers are. We're just going to put the mean in the middle. And then drawing lines to represent 3 standard deviations, so 3 lines. So 1 standard deviation, 2 standard deviations, 3 standard deviations. Going the opposite way, they have to be negative. You don't have to fill in the percentages. So the question says to sketch a normal curve, which we now have sketched, shade the region under the curve for the values less than z, based off of the given score. So our score is 2.7. 2.7 is between 2 and 3. So about right here is 2.7. So that number falls within my standard values from the empirical rule. And then it says shade everything less than that. So you can see that most of the curve should be shaded. And then use the chart to find the probability or the percent of the data that would be shaded in the curve, the percent of the data that would be less than 2.7. And again, you can think of that as 2.70. So look in the chart. the z-score chart, what percentage of the values are less than 2.7?
99.65.
99.65%. Which, if you look at the chart, pretty much all of it is shaded. 3 standard deviations is 99.7, so we're really close to that. The next one is negative 1.6, so we would do a similar format. We'd have the mean. This is on the negative side. So negative 1.6 is going to be between negative 1 and negative 2. We would shade, and then look that number up in the chart.